Hello. So we are now entering section 5.1 and we're looking at what are called probability distributions and random variables. So a probability distribution just lists all the outcomes of a variable along with corresponding probabilities. And then we can answer questions involving this discrete probability distribution. So in the original problem, we have a probability that's missing for the horse named Collie. It says complete the table by finding the probability that the horse Collie will win. Show your work. Well, one of the properties of a probability distribution is that all the probabilities must sum to 1. So we just add up these other probabilities, subtract from 1, and we're left with 0.23. And that's going to be the chance that the horse Collie will win. And then our second question just asks, which horse is most likely to win, the horse Collie or the horse Mojave Heat? Well, we compare the two chances. Collie is 0.23, Mojave Heat is 0.12. This is larger, so Collie actually has almost double the chance of winning. And then it asks which is the most unusual. Well, the horse Clip Clop has an extremely low chance of winning. So that would be unusual for this type of race. However, if that horse does win, whoever betted on the horse will have a huge payoff. But we would say Clip Clop because its probability is extremely low. Then it says find these extra probabilities, the chance that War Admiral or Desert Rose wins. Well, or always means add. So we look up the chance that War Admiral wins, add it to the chance that Desert Rose wins, 0.45. And then finally, what's the chance that Clip Clop does not win? Well, that's going to be 1 minus the chance that it does win. So 1 minus 0.04 is 0.96. So it's a pretty high chance of losing there. But so you can answer, once you construct this probability distribution, you can answer several questions based off the distribution. On the second page, they're going to have you construct problems. So let's look at the third example here. They're just saying, just build a probability distribution for the outcomes 0 through 4 with the following probabilities. So we construct our table. We list all the outcomes at the top row, all the probabilities at the bottom row, and then just make sure that the sum of the probabilities is equal to 1. So we'll have you work on the first two. Also later on, we're going to have to graph these probabilities distributions. So here's an example where a coin is flipped 4 times and we're counting the number of heads. So that could be 0, 1, 2, 3, 4. And then we list the corresponding probabilities below. But now we want to graph this distribution. Well, it's going to be a bar graph. On the x-axis, we list the number of heads, 0 through 4. On the y-axis, that's where we graph our probabilities. So the probabilities are the heights of the bars. And we're going to use increments of 0.05. So 0, getting 0 heads is 0.0625. So that just goes up a little bit past 0.05. To get 1 head, that's 0.25. So you draw a bar up to 0.25 and then construct the rest of the bars. And that's your bar graph. And then we have, we want you to go back to these other two examples and draw the graphs for those examples. Now we're going to just look at some of the definitions that we'll be working with for variables and variable types. Suppose we conduct an experiment by flipping a fair coin 4 times. Are the outcomes heads and tails values of a categorical or quantitative variable? Well, it's going to be categorical because it's non-numerical, and basically it's nominal, meaning they're just names that we assign. So categorical and non-numerical. And it says, what about the outcome, the number of heads in 3 tosses? Is that categorical or quantitative? Well, that's quantitative. because you're actually going to get an actual number when you toss the coin 3 times. So it could be 1 head, 2 heads, 3 heads, 0 heads. So numerical. A random variable is a numerical measure of the outcome of an experiment. So remember, it's numerical, so quantitative variable. And then we say random variables are typically denoted with capital letters, such as capital X and capital Y. So it says, suppose we randomly select and test blood type. Is the blood type a random variable? No, it's categorical, because blood type is not numerical. It's based off 4 letters. It's nominal, so no. And since it's not quantitative, that means it's not a random variable. Suppose we toss a coin 4 times and we want to get the number of heads. Well, that is quantitative. And then still tossing the coin 3 times, it's saying X is the number of heads, and then they're asking us, is this type of data set finite or infinite? Well, infinite means it just, you keep counting forever and ever. Finite is the opposite. You just count up to a certain number of values that we can count. It's typically a small set, but it could also, so this has to be finite. So it is a finite because we're tossing the coin 3 times. 3 would be a finite number. And then finally, we look at discrete versus continuous variables. So we say that a variable is discrete if it increases or decreases in discrete increments. So if we have the sequence 4, 7, 10, 13, they're all separated by the number 3. So this right here would be, these are discrete values. A random variable is continuous if it has to flow through all the numerical values. So for any type of interval, let's say from 1 to 2, it doesn't just simply jump. A discrete jumps from 1 to 2. An interval flows from 0.1, all the fractions in between. So anytime you're dealing with just straight whole numbers, it's typically discrete, and there's gaps between them. Anytime you're dealing with numbers that have fractional, that has to move through the fractional part, they are called continuous variables. So if a coin is flipped 3 times, that's discrete because 3 is a discrete number. If we randomly select a student who took a true-false test with 100 questions, well, you're going to get a numerical value, though, and typically they're not going to be fractional. So let's say someone got 75 out of the 100. Another student got 80 out of the 100. These are discrete values, and yeah, because there's going to be gaps between the numbers. You randomly select a mutual fund. X is the number of companies in the portfolio. That's discrete because it's just, once again, we're counting whole numbers, and there's going to be gaps between those whole numbers. So you could have 10 companies, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The gap is 1. Now, where we start dealing with continuous variables is examples like height, weight. So if we select 50 students and we want to X represents the average weight, well, weight is continuous because if someone gains, let's say 5 pounds, it doesn't just automatically jump from 150 to 155. It has to flow through all the fractional parts to get there. And also, if we randomly select a woman, the exact height is X. Once again, similarly to weight, height also has to flow through all the intermediary values. So someone who's 5'7" and who grows to 5'10" in a short period, they have to flow through all the other numerical values. So that's continuous. So our video will stop here. This covers section 5.1. You will continue with the next video on section 5.2. Thank you.